Robots can move, flash lights, and follow complex instructions. But have you ever wondered how their mechanical parts know exactly what to do? The secret lies in a tiny computer called a microcontroller. It acts as the brain, receiving digital commands and controlling the robot's physical actions. Think of a robot like a human body. The microcontroller is the brain, wires are the nerves, and motors or lights act as the muscles. Just like your body needs a brain to move, a robot needs a microcontroller to interpret signals and trigger its mechanical parts into motion. Every robot is built from two essential components: hardware and software. Hardware is the physical body, like the board, wires, and sensors. Software is the set of digital instructions that tells that hardware how to behave. Without software, the hardware has no purpose. Conversely, software without hardware has nothing to control. It is the combination of both that brings a functional robot to life. The Arduino Uno is a fantastic board for beginners to learn these concepts. It features a USB port that supplies power and uploads your code. The board also has numbered digital pins. These pins are the gateways that allow the microcontroller to send or receive electrical signals. You will also see a connection marked GND, which stands for ground. This is the return path that completes the electrical circuit. Electricity must always travel through a complete path to work. Without this return path, your components simply will not function. A program gives the microcontroller specific digital instructions. For instance, setting a pin to high sends 5 volts of electricity. When you set a pin to LOW, the output drops to 0 volts. This simple binary switch is the foundation of all digital logic. High turns a signal on, and LOW turns it off. This is how a digital thought is translated into a physical electrical action. There are several ways to program an Arduino. Beginners often start with block coding, which uses colorful, interlocking instruction pieces. Another option is a browser-based text editor. This allows you to write code online and upload it directly to your connected board. The third method is the Arduino IDE, a full application you install on your computer. It offers the most control for advanced projects. Block coding is perfect for learning the logic of programming. It helps you visualize the flow of instructions without worrying about syntax. Text coding is used for larger projects where you need more precision. Both methods are just different ways to write the same instructions. A block saying set pin to high is functionally identical to the text code digital write. Both tell the board which pin to activate. Before you connect real hardware, it is smart to use a circuit simulator. Tinkercad Circuits is a great tool for this. A simulator lets you build virtual circuits with LEDs and resistors. It is a safe sandbox to test your ideas without damaging components. If you make a mistake in the simulator, you can just reset it. This makes learning much less intimidating for new inventors. Inventors follow an iterative loop. They connect the hardware, write the software, test the design, and then refine their work. This cycle of connecting, coding, and testing is how real-world inventions are perfected. It is a process of constant improvement. Do not be discouraged by mistakes. They're not failures, but rather useful clues that help you understand how your system works. Now, let us build a simple blinking circuit. You will need an Arduino, a resistor, an LED, and some jumper wires. Connect digital pin 13 to one side of your resistor. Then, connect the other side of the resistor to the long leg of the LED. The long leg of the LED is called the anode. The short leg, the cathode, must be connected directly to the GND pin. The resistor is a crucial safety component. It limits the flow of electricity to protect the LED from burning out. When pin 13 is set to high, electricity flows through the resistor and the LED, completing the path to ground. If your circuit is not complete, the LED will not light up. Always double-check your connections if things do not work. The blinking program follows 4 steps. First, set the pin to high to turn the light on. Then, wait for 1 second. Next, set the pin to LOW to turn the light off. Finally, wait for another second before the loop repeats again. Without those wait instructions, the LED would blink so fast that your eyes would only see a constant, dim glow. An Arduino program is organized into 2 main functions. The setup function runs only once when the board is first powered on. The loop function runs continuously as long as the board has power. This is where the main logic of your robot lives. Inside the code, pin mode prepares the pin for action. Then, digital write sends the signal, and delay pauses the program. Arduino functions make coding very accessible. However, you can also use lower-level embedded C to control the microcontroller directly. This involves interacting with memory registers. It is a more advanced technique that gives you direct control over the hardware pins. The ATmega 328P chip inside the Uno uses specific registers to manage its pins. It is a powerful way to understand how computers work. While register level C is complex, it is the language the microcontroller speaks natively. It is great for optimizing performance. When you upload your code, the microcontroller begins executing your instructions. The LED will start its rhythmic blinking pattern. This blinking light is the electronics version of Hello World. It is the first sign that your code and hardware are working. It proves that your circuit is complete, and your software is running exactly as you intended it to. A blinking LED might seem simple, but it teaches the same logic used in complex robots. It is all about inputs and outputs. A sensor can act as an input, providing data to the microcontroller. The code then makes a decision based on that data. Finally, a motor or buzzer acts as the output. This is the fundamental cycle of all automated systems and robotics. By combining these steps, you can create robots that avoid obstacles, follow lines, or even monitor your houseplants. Every advanced robot, from factory arms to space rovers, begins with simple instructions just like the ones in this project. Now, try changing the delay values in your code. Change 1000 milliseconds to 500 to make it blink faster. You can also try 2000 milliseconds to make the blink slower. Observe how the system responds to your changes. Learning robotics is all about experimenting. Change an idea, test the result, and discover how your robot interacts with the world. Start with one light, one instruction, and one experiment. You are now well on your way to becoming a skilled robotics engineer. Keep practicing your code and building new circuits. Every small project you finish builds your confidence and your technical skills. Try adding a second LED to your circuit. Can you make them blink in an alternating pattern using your new skills? Experimentation is the best way to learn. Do not be afraid to break things or try unconventional ideas in your code. The world of robotics is vast and exciting. There is always something new to discover, from sensors to advanced programming. Stay curious and keep building. Your journey into the world of creative robotics has only just begun today. With every line of code you write, you are learning to control the physical world. Keep creating and keep innovating.